Hi everyone, Titus here for part 2 of the Flashbang special effect in Unreal Engine, and in this video we'll call the effect from the first person character blueprint to actually see a screen whiteout effect when we actually get flashbanged. Let's not waste any time, jump right into it. Okay, so last we left off we created the actual material for the post-process effect, and we created the flashbang blueprint. In this one, we're going to be working primarily in the first-person character. You can find that under the first-person folder, Blueprints, and it's called BP_first-person character. Alternatively, if you are doing the third-person template, it'd be BP_third-person character, or if you're doing a custom, it'd be whatever your player pawn is. We created a flashbang. We created some input nodes that we still haven't set up. We'll need to do those in a second. But let's work on the skeleton of the actual character here. So we need two variables. The first one's going to be a flash zone. This is going to be the distance to which the flashbang is effective. So within a certain proximity, the flashbang will white the player's screen out. Outside of that, it will not. The second variable we'll need is going to be the flash amount. This is going to give us the ability to get and set a scalar value so we can influence our material parameter to actually get the effect going. Once you have those created, hit compile and you'll have access to their values. For the flash amount, 0 is okay. The flash zone, try 500 starting off. And then for the components tab, we have a couple different options for the post-process volume. You can create a post-process volume in your actual level map, and you can either set it unbound, where it'll affect everything infinitely, or you can scale it to a particular size and set it in a particular region of the map, and your special effects will only happen in that small region. For this particular special effect, I'm going to set it on the player character instead, because the player should be able to get flashbang from anywhere on any map, so it just makes more sense. So I'm going to hit add, search post-process. I'm going to call it PP_flashbang. With it highlighted, let's find the rendering features, expand that, find post-process materials, expand that, and we're going to add an array element, and we're going to choose an asset reference. The asset reference we want is the post-process effect that we created in the first video. So that's going to be PP_flash effect. So if we go here and search PP_flash effect, you'll notice I have two. The one with the underscore is the one I made to show you, basically to demo the effect at the beginning of the video, so you can ignore that one. It should be the top one, or whatever you named it. We'll compile and save. And now we can actually go to our event graph, and let's begin working on the distance check. So easy way to do this is just drag off the distance value and do greater. So is the distance greater than our flash zone? We can drag that into the other input pin. If it is, let's drag off and create a branch. And then from the branch, we'll hook up the conditions. And then if they're greater than our flash zone amount, we will do a print string and say far, as in the player's too far. If they're within the distance, we'll do a print string and we'll just say close, so we know that they're close enough to get flashed. Compile and save. Now we're going to head back into our project and let's find our blueprints folder. Let's open up the BP_flashbang, and if you notice, when we make a call to the flashbang code from our first person character, we never input the distance, or the facing angle for that matter. So let's go ahead and do that now. We can just simply right click get distance. It's a nice little built-in function. The target self is referencing our little flashbang, so that's okay. The other actor needs to be the first person character. We can get a reference to that because off of begin play we did a cast to the first person character, so we can actually just pull off the blue pin. So as first person character, drag off that and you can plug that into the other actor and that'll work just fine. And then from the return value, we can just drag this into the distance field, compile and save. And 500, let's see if it's how bad it is. So press G, walk back. So you see it says far. If I just press G, it's close. So that's working. Close. Let's see if I can just chuck it far enough. No, so I have to actually walk back. 500 is, yeah, there we go. Then you can play with the value. You know, you can bring it closer or bring it farther away. So depending on whatever project you're working on, you can change that just in the first person character, just on the flash zone. So basically decrease the zone. So the flashbang has to be closer for it to actually affect the player, or increase it if you want them to be more susceptible to flashes. So either way. But all right, so this looks pretty good so far. You can delete these debug lines. And now what we're going to want to do is work on the functionality where the player has to look at the actual flashbang to get flashed. So if they're looking behind them, their screen shouldn't actually get, you know, affected. To do that, we're going to create a function, and we'll call this the flash angle. And our function is going to have one input and one output. The input is going to be the grenade location or grenade lock. It's going to be of type vector. The output pin, we're going to name that is not facing question mark. And that's going to be of type Boolean. Now in order for this to work, compile and save, we need to be able to feed in the grenade location. So let's go back to our event graph and let's build out this code a little bit more. So what we can do is if the distance is too far off the true, we don't really need to do anything. But if it's close enough, we then want to call our function, which is flash angle. And what we can do is feed in the facing angle into the grenade location. But if you remember, the facing angle isn't getting anything right now. So let's head over to the flashbang code. There's our facing angle. We need a way to actually get a reference to, you know, where this flashbang is actually at. The way we can do that is we can get a reference to the bomb, the static mesh. So drag it out. Off of that, we can drag and do get world location. And then from the world location, you can just plug in that vector, compile and save. That'll then feed when the flashbang event gets called. It'll feed from this pin. And if the distance is true, or I'm sorry, if the distance evaluates to false, it'll call the flash angle function and feed in that vector into the grenade location. So then from the grenade location, we can actually do some math here. So we'll want to get a reference to our first person character, or I'm sorry, our first person camera. So we'll drag that out there. From the first person camera, we can do get world location. And then from the world location, we can drag off that and do find look at rotation. And I want to start from the player. So I want to look at the basically the camera. So this thing right there, this big giant camera. So we're going to start from the front of the camera, and then we're going to have it look at the vector of the grenade, basically where the grenade is located. And that's going to give us this rotator, which we're going to right click and split. I'll explain why in a second. I then want to get the actual world rotation. So this is the true world rotation of the actual player's camera. So on the first one, we're finding a look at rotation. So we're basically calculating like, hey, if the camera were to look at the grenade, what's that look at rotation value? Then we're going to subtract that against the actual rotation of the camera. And if those values subtract and they fall within our specified range, which we can, parameterize and set to whatever we want. You can do like 180 degrees or 120 degrees, whatever your field of view you want it to be. Then we can mark it true, and then we can flash the player or not. So we're going to right click on the return value and split this struct pin. Now, a more realistic way to do this is to factor in both the pitch and the yaw. I'll demonstrate that a little bit more later. For simplicity and just for this tutorial, we're just going to use the yaw. And I honestly think that's probably better for a gameplay mechanic anyways, because it would be real easy for a player to not get flashed by looking down or looking straight up at the last second. So which maybe that's what you're going for in your actual project if you want more realism, I guess. So we'll come off the Z value and we'll do a subtract. And we're gonna come off the Z value of our actual looking rotation. And then we can drag off this one pin and we can do greater equal. And then we'll drag off the same pin and we'll do less equal. And this is going to be our range. So if I want to do a 120 degree field of view, I can do between 60 and negative 60. If I want a wider cone, like 180 degrees, I can do 90 and negative 90. You can, of course, parameterize this, and you can affect it with stats. You can do all sorts of, things with this where, certain players are going to be more susceptible to getting flashed. A lot of, interesting things you can do kind of just with this little simple function. But whatever field of view you decide on, you basically drag off the Boolean pins and you do a or Boolean. You can drag them both off here. And then you'll hook up that Boolean for the is not facing for it to evaluate. Oops, drag this down a little bit. And then I'm also going to drag off here and do a print string. And I'm going to drag a third pin so we can actually see the values so you guys can kind of see what I mean. All right, so we got the function set up. Let's go back to the event graph. So when this function actually runs and evaluates, we need it to actually do something. So obviously we're going to pull off into another branch and we'll hook up the conditions. So if the player is not facing, so if that marks true, then they're not facing at the grenade, right? So we should print a string and just say missed. And then if it's false, that means they're looking. So we'll print a string and we'll say flashed ya. Now we compile and save. We can debug our code. I'm looking at the relative location, you can see it says flashed you. If I turn 90 degrees, you can see I was 110 degrees and I missed. If I turn this way, flashed you, it was only 69, so it was a little bit closer. So let me try right around there, 113 degrees and I missed. The reason this isn't realistic, what I was saying earlier, where you might want to take the pitch into account, because if I throw the flash straight up and look straight down, I got flashed because the angle is only 37 degrees. It didn't take account into the pitch. Or if I throw it straight down and look up, I'm getting flashed there. So, you know, depending on the level of realism you're trying to go for your project, you know, maybe that's a consideration of why you might want to look at the pitch as well. But I think for a gameplay mechanic, at least in my opinion, I would probably prefer not to look at pitch, just because if somebody throws a flashbang close, and if the player's quick enough, he's going to look down, or they're going to look down, I should say, and it kind of ruins maybe your core gameplay mechanics. So that's more of a personal choice depending on your project. But yeah, so far the code's working, so we will delete these debug strings, and now we can actually do the actual code. So if it evaluates to true, we're going to want to set our flash amount. And we're going to want to press Control D to duplicate that. And we're going to hook up these pins here. So if they're not looking, the flash amount should be 0. If they're looking, the flash amount should be 1. What we can then do is we can run a search for set scalar parameter value. And we can hook up our flash amount into our parameter value here. Or you can hook up both pins, I guess, either way. And we're going to hook up the execution pins to the same scalar parameter value. For the collection, this one's going to be our material parameter flash intensity collection. And for our parameter name, that one should be intensity, which is whatever we named the parameter name here. So if we drop this down, you see intensity shows up. So we'll select that one. All right, with that set, we now need a way to actually kind of lerp this through. So let's actually set a quick delay of 1 second. I find works pretty good. And then we're going to do it with a timeline. So we'll do timeline, we'll add timeline. We'll just call this the flash timeline. I don't like play. I like using play from start. It's more consistent because it's going to play from start every time you get flash. So I think that makes more sense. Double click on the timeline to modify it. I'm going to do a 3-second timeline, I think. We'll add a track. It's going to be a float track. I'm going to call the float track the flash alpha, or alpha, or, you know, kind of whatever you want. But it's going to be an alpha value, so just be aware. You can right click anywhere in the graph, add a keyframe. We're going to do 0, 0. So at time 0, it's going to have a value of 0. And then the second one you're going to add, so add a second keyframe. That's going to be the end of the length. So if you decide on 5 seconds, 7 seconds, 3 seconds, however long you want this effect to last for, basically. So I did 3 seconds. That's going to be a value of 1, which is the maximum intensity of our flashbang effect. So you could plug in values here too, where you do like you can do like a random value between 0, like clamp it between 0 and 1, so you can get more intense flashes randomly. So there's a lot of things you can do with that as well. But yeah, when you compile and save that on your timeline, you'll see you have the flash alpha actually comes up now. What we can then do is on the update, we drag off this and we do set scalar parameter value. And it's kind of more of the same. So the flash intensity, parameters intensity. What we do is we lerp. So let's do lerp. We'll plug the return value into the parameter value here. And then our flash alpha is going to go into our alpha here. And we're going to be lerping between the flash amount which is this one here, and then our B value, which is normal, which would be 0, right? So basically you're going from flash to unflashed over 3 seconds of time. And then just as a debug line, just to see if this is running right, I'm gonna, on the finished, I'm gonna do a print string, and I'm just gonna say, all done. Compile, save, let's check our code. We'll throw a flashbang out. All right, we got flashed. 3 seconds later, we should kind of come back to normal. I turn away. It's a miss. Didn't flash me, still ring me though. That's because their audio is coming from the blueprint on the grenade, but turn a little bit. See, it's 78 degrees, so I still got flashed and I can't see. I throw it up and look straight up. That still flashed me. If I throw the grenade over there, you can see it's outside the flash zone, so it didn't affect me. And it probably shouldn't have the ringing either, but we'd have to change the implementation of our code. But yeah, so I think that is the majority of the flashbang effect, or pretty much everything I think I wanted to cover anyways. But yeah, you got a lot of different options with this code. So you can do add all sorts of different parameter values, change your flash intensities, get different effects. You can even play with the special effects and get a different type of flash effect as well, a different color, what have you. So a lot of different options there. You can see it didn't take a whole heck of a lot. We were able to do this in just 2 videos. But yeah. All right, everyone, this concludes the UE Flashbang Grenade tutorial. If you like this content, please consider checking out my Blender Flashbang miniseries, where we actually model the grenade into a game-ready asset. In the future, I'm going to be working on some chaff and smoke special effects, so be sure to check those out when they drop. But as always, thanks for watching, consider subscribing, and see you on the next one.